So I'm an infectious disease specialist, and I'll be speaking about meat production and consumption, particularly the public health concerns farm to fork. So I don't know if many of you are aware that industrial food animal production systems really comprise almost all of the meat and dairy in the US. And thousands of cattle, tens of thousands of pigs, hundreds of thousands of chickens are confined to single facilities, and this produces enormous amounts of animal waste. And these production systems raise enormous public health concerns for the workers, the rural communities, the consumers, and the general public. This is really what the shift from extensive to intensive farming looks like. The public health concerns are towards animal welfare. The overcrowding that occurs in these facilities induces stress and susceptibility to infections among the animals. And there is health concerns for the workers. So most of these facilities are not OSHA regulated. So workers typically do not have, protective suits or other protective equipment when they're working with these animals in these crowded conditions. And there is transmission of diseases from the animals to the workers, who then, can spread infection back to the community. And infections from consuming raw, undercooked meat, and feed additives and antibiotics that are added to the production system can contaminate the food supply as well as the water supply in these rural communities. And there is emergence of antibiotic resistance, which erodes effectiveness of life-saving drugs. And finally, there is emergence of novel viruses. So surprisingly, there is an enormous amount of antibiotics that are used in livestock, and it comprises about 80% of all of the antibiotics that are used in our country. And only a small fraction of it is used for treatment of animals with infection. So majority of or for prevention of infection, and majority is actually used in subtherapeutic doses in the animal feed, and that is to promote growth in intensive animal farming. And so it was through some experiments back in the 50s and 60s where it was discovered that if animals were fed subtherapeutic low amounts of antibiotics, that their conversion efficiency was increased, so that is, that they were fattened quicker, and this led to this widespread practice of using these low amounts of antibiotics. And next one. So how did this practice come about? So in the early part of the 20th century, there was a meat shortage, and this resulted in protests and boycotts, and eventually, to these experiments to see how the production could be ramped up. And eventually, the U.S. scientists found that adding these antibiotics to animal feed increased growth. And like I said, by the turn of the century, 80% of the total antimicrobial use was for non-therapeutic purposes. This is what the graph looks like. So you can see just over the first 10 years in the century, there was about a 50% increase in antibiotics that were given to livestock. And these antibiotics are not just esoteric drugs, but these are antibiotics that are used for treatment of human diseases. So when animals are fed these low-level antibiotics, this results in pressure on the bacteria that are in the gut, resulting in emergence of resistant bacterial species. And these resistant bacteria then can be transmitted to the farm workers and then to the community, and also they can be present in the meat that's marketed, and if it's not cooked properly. And finally, fertilizer and water containing animal feces. And it's surprising that there are actually not a lot of regulations around how the animal waste is disposed of. So a lot of it just kind of returns, either back into animal feed or, into agriculture. And from the farm and back again. So again, this shows a schematic of how MRSA, which is methicillin-resistant Staph aureus, how feeding animals with antibiotics can result in emergence of MRSA, and then how the MRSA can go into the community. And some of this transmission can occur again through the workers in the factories, but again the transportation trucks, flies, and again animal waste being animal waste contaminating rural lands and communities. So this here shows an example of cephalosporin, which is a commonly used class of antibiotics, showing what happened over a period of about a decade. And as you can see, this is Salmonella strains, which cause infections among humans, and the emergence of resistance. So, for example, 97, there was maybe less than a couple % prevalence of resistance in these bacterial species, but over a 10-year period, the prevalence was as much as 10 to 15%. So this is just to illustrate how wide the use of antimicrobials for growth purposes is. Here again, 70% of the antibiotics are consumed by animals just for growth. And this here, can't see the name of the countries here, but antibiotic use in livestock by countries. So there is a large variation across the world. The arrow is where the US stands, and some other Scandinavian countries have introduced more regulations, so they have much lower levels of antimicrobial use in their livestock. And the US is beginning to ramp up some of their regulations so they can control antimicrobial use. So briefly want to touch about also emergence of novel viruses, and it's through the animal-human ecosystem interface. So over the decades, we have seen a number of viruses. You may hear about different influenza strains emerging in the communities, and other viruses such as Nipah, SARS, Ebola, MERS. So many of these have resulted through overlap of the animal-human ecosystems, whether this occurs in the industrial production systems where the animals are living in overcrowded conditions, or also animal markets where different animal species are again in overcrowded conditions, and there is a lot of cross circulation of viruses. So novel influenza viruses have appeared through industrial production systems as well as in live meat markets, and largely from frequent contact among large populations of hogs, birds, and humans. And these really provide ideal conditions for the generation of new viruses. And again, live animal markets are another big contributor. So here is an example of a novel avian influenza virus, H7N9, and this was through a reassortment of viruses containing gene segments that came from 4 different bird species. 2 were wild and 2 domestic. And so when these virus species appear and then infect humans, these humans are really non-immune to these viruses and can result in large epidemics. Another example is bats, which interestingly carry about 66 different virus species. And we've heard of a number of different epidemics that have appeared over the recent years. And this has again been through spillover dynamics where there are large markets for wild animal meat as well, and that's where some of this overlap and overlap of ecosystems happens, either between the bats and humans directly, or between bats via some other animal species where viruses are transmitted from bats onto pigs and then onto humans. So again, resulting in new viruses such as Ebola. So to summarize, our modern meat production systems have resulted in large public health concerns. These systems with intensive farming practices and live animal markets impact animal welfare, inducing stress and increased animal susceptibility to infections. Worker health is compromised with transmission of diseases from animals to workers, who then spread infections to their communities. And also the communities, so it's interesting, I was looking at the map this morning of where a lot of these big industrial operations are. So compared to maybe 20 years ago, where there were small operations that occurred throughout the country, most of these operations are now in the southeastern part of the country. So in rural communities, and those again, like there is not much OSHA regulation, and so there are a lot of odors, there are a lot of contamination of the soil there, and different diseases occurring in those communities related to the industrial production systems occurring in those regions. And the feed antibiotics, contaminating the food and water supplies, and antibiotic resistance, as we saw, emerging through feeding these animals with low subtherapeutic doses of antibiotics, then eroding the effectiveness of life-saving drugs, and finally, emergence of novel virus strains and zoonoses. I want to end with this quote, and I think we had some other talks end with the same quote as well. So nothing will benefit health and increase the chances of survival of life on Earth as the evolution to a vegetarian diet. Thank you very much.